Have you ever seen a stunning image from the Hubble Space Telescope, like this one of the pillars of creation, and been completely blown away by its beauty and detail? It's a window into the vastness of our universe, showing us things that are literally light years away. But then you see an image of something much closer, like a comet passing through our own solar system, and it looks, well, like this: a blurry, pixelated blob. It seems absurd, right? How can we take crystal-clear pictures of galaxies millions of light years away, but a comet in our own cosmic backyard looks like it was photographed with a potato? The answer lies in a few key scientific and technological principles. It's not about the distance, but about the conditions under which these images are taken. First, let's talk about the Earth's atmosphere. For those of us on the ground, the atmosphere is like a thick, turbulent blanket of air. It's what causes stars to twinkle. For astronomers, this twinkling, or astronomical seeing, is a nightmare. It blurs and distorts the light from celestial objects, making it impossible to get truly sharp images. The Hubble Space Telescope, on the other hand, is in orbit above the atmosphere. It has a crystal-clear, unobstructed view of the universe. This is the single biggest advantage of a space telescope. Second, there's the matter of exposure time. Deep space objects like the pillars of creation are incredibly faint. To capture their light, Hubble has to stare at them for a very, very long time. We're talking about hours or even days of exposure. This allows the telescope to collect enough photons to create a bright, detailed image. Now, think about a comet. It's a relatively small, fast-moving object. You can't just stare at it for hours on end because it will have moved across the sky. The exposure times for comets are much shorter, which means less light is collected, resulting in a fainter, less detailed image. Finally, there's the nature of the objects themselves. The pillars of creation is a vast, sprawling nebula, a giant cloud of gas and dust where stars are being born. It's a huge and relatively bright target. A comet, on the other hand, is a tiny, icy rock, often only a few kilometers across. It's a much more challenging object to photograph in detail, especially from a distance. So, to sum it up, the reason Hubble can take such breathtaking pictures of distant objects is because it's above the Earth's distorting atmosphere, it can use incredibly long exposure times, and it's often looking at large, bright objects. The blurry comet picture, on the other hand, is the result of a ground-based telescope looking through the atmosphere at a small, faint, and fast-moving target. It's not an absurdity, but a testament to the incredible challenges and triumphs of astronomical imaging. The fact that we can even get a picture of a comet like 3I Atlas is a scientific achievement in itself. Thanks for watching.